Hello everyone, in this video we are going to see about how to insert and delete elements in linear array. Actually what is linear array is one dimensional array. It may be a column array or a row matrix. So here what is inserting is you are adding some element in the array. So you have to, the function is used to insert an element in an array. So here the function contains four arguments, linear array, the name of the array, n is the number of elements and k is the position in which you want to insert the item, and item is the real value you want to enter into the array. So here LA is the linear array. Okay. So now the algorithm inserts an element item into the kth position in the linear array LA. Let us see the algorithm. Step 1, we have to initialize the counter. So here n is the number of the elements in the array, which is the size of the array. Now suppose for example there are 5 elements in the array, and if you are inserting one more element, the size becomes 6, n becomes 6. So initially we make j as the value of the size of the array n. Repeat the steps 3 and 4 while j greater than or equal to k. Actually what this step mean is, as long as j is greater than or equal to k, we have to repeat the steps 3 and 4. So what is the step 3 and 4 does is, the step 3 move the element downward, and that is done by this statement set LA of j plus 1 is equal to LA of j. That means suppose if you want to insert some element in the one position, we have to make space for that element, so that we are just pushing the element downwards. That is the step done here. And then once you push the element, we have to decrease the counter also. So j is equal to j minus 1. Now these are the two steps, it has to be repeated. So as long as this while j greater than or equal to k means, as long as the position of k is greater than or equal to j means where this element position k sets into the variable j, that is the size of the array, then we can insert the element into the array, and these steps are done. So the element is pushed and the counter is decremented, and then now the space is created for the element. So you can insert the value set LA of k is equal to item. Now you have made some space for this item, and we are pushing that item into the space which is created now, and which is the kth position. Because suppose if you want to insert the element in the third position, now k is equal to 3. Okay, so now let us see with an example. And reset set n is equal to n plus 1 means now we have inserted one more element. Now the size becomes plus 1, because suppose we are having 5 elements in the array, if we are adding one more element, it will become 6. So n is equal to n plus 1. So that's all. The algorithm is over, which helps to create the insertion of an array. That means inserting an element into the array. Let us see the same with an example. It's easy to understand. So this is the insert operation in an unsorted array. What is unsorted array is, we are given an array in which the elements are in any order, any random order. There is no ascending or descending order. So now this is the item. Okay, this we are going to insert into the original array. Okay, so now here this is a array which is having elements 1 2 3 4 5 positions are there. The elements are 5 1 4 2 and 6. Now I want to insert the element 3. Suppose if you want to insert the element somewhere in between this array elements, you have to shift 1 towards. For example, I want to put this 3 after 1, I have to shift to 4, and then a place will be created. Then only we can insert the element 3. So this is was done in the this is the line of statement that does. Suppose I want to insert an element into an array, I have to push the element so that we can make space for the element to be inserted. So I am creating the space using this position. So once I create the position, now I have to insert the element in the particular position. For example, after 1. So now j is equal to j minus 1 because we have incremented the counter by shifting into the next position. So we are decrementing by 1 in order to make the space in between 1 and 4. So in that place we can insert 3. So that is done by the equation. This is the one. Okay, LA of k is equal to item. That is the line that does the inserting operation into the array. So now this is the original array. After inserting the element, the array becomes 5, 1, 4, 2, 6, 3. In this example, the 3 is inserted in the last position. When you're inserting the last position, there is no need to push to make space in between. Yes, suppose if you want to insert an element in the in-between space, you have to push and make space and then insert the element. If you want to insert at the end of the array, there is no need to make the space because we are going to only make the element at the end of the array. So just we can increment the counter and then we can just put the element into the position. Suppose here j is 1, 2, 3, 4, 5. What I can do is j is equal to j plus 1 and then a of j plus 1 is equal to k, which is the element. I can just insert without any pushing. Okay, so that's the difference here. So in an unsorted array, the insert operation is faster as compared to the sorted array, because if you are using an sorted array, that array order has to be maintained. We have to maintain the array order. So we have to find where the position, where the item has to be inserted, to find the position, then to make the space, then to insert. So that requires 3 steps. So suppose if you wanted to insert element in an unsorted array, simply to add some element, you can just push into the end of the array. So it is easier. Here there is no order after insertion. Okay, so that's the difference here. If the array is sorted and if you want to insert one more element, we have to take care in such a way that when you insert the new element also, the array is always in order. So that is the concept of inserting element in the sorted array. But in the case of unsorted array, simply we can add to the end of the list. So there is no pushing and making room. So there is no operation for pushing the element and making the space. So the operation is faster. That is what explained over here. In an unsorted array, the insert operation is faster as compared to the sorted array, because we do not have to care about the position at which the element is to be replaced. Now the next operation is the delete operation. So here we are going to remove the element. So again this contains the 4 parameters: the array, size of the array, from which position you want to delete, which is k, and what you want to delete, which is item. So here LA is the linear array with n elements and k is the positive integer. Positive means the position cannot be negative. Okay, you can say 1, 2, 3, 4 position. We cannot say -1 position. So the k is always a positive integer, such that k less than or equal to n. That means this k value is always less than the array size. Okay, and then this algorithm deletes the kth element from the linear array. So what are the steps here? Set items equal to LA of k. So which element you want to remove, we have to copy the value into the item variable, and then since you have copied and we have removed, we have to less than the space. In insertion, we have pushed one space, we have created one more space. Now we have to remove one space. For that we have to do repeat for j, it is equal to k to n minus 1. That means from the position you have deleted till the last position of the array, we have to move the element to upwards. That means you have to push up. Okay, so move j plus 1th element upward. That is done by set LA of j is equal to LA of j plus 1. Let us see the example to easily understand this concept, and then that's all. Once you made the arrangement, now we have to finally, since we have removed one element, the size becomes n is equal to n minus 1. Suppose in the array of 10 elements, if you remove 1, it will become 9. So n is equal to n minus 1, exit. So that's all the delete function. Let us see with the example here. Suppose I want to delete the element 3. Okay, so now we have to find out from which position the element 3 is here. So it is in 1, 2, 3, 4th position. So I have to first find out the position where 3 is. So I have to check whether this 3 is equal to the first position, second position. I have to keep on checking till the element comes. Now 3 is checked with the 5, it is not the element, so move to the next one, it is not the element, move to the next one, it is not the element, and when it is moved to this counter, 3 is equal to 3. So this is the one you want to delete. The position is 4. So what you will do, you have to remove this. After removing, this is the array 5, 1, 4, 2, 6. So once you remove the particular element, the gap will be produced. So this gap has to be adjusted. So 2 has to come in the third position, which is blank now. Then 6 will comes to the 2 position. Okay. So now 1 position is lessened. We have to subtract the n is equal to n minus 1. So that's all the delete operation. So here, in the delete operation, the element to be deleted is searched using the linear search. That's what I just explained now. We have to check linearly from the first element till the last element or till the element is reached. Now I have checked for 5 linearly, 1 next to 4, and then finally I got this. Suppose if I am asked to delete element 8, for assume an example, here it will keep on checking linear search till here 8 is not found. Then it will say that the element you want delete is not inside the list. The message will be, this is the message will be displayed on the screen. So what you have to do, once you delete this and then delete, the operation is performed, followed by shifting the elements. What is shifting the elements means, this 3 has left the space because we have removed. So we have to move 2 to the 3 position and 6 to the 2 position. We are shifting elements backward. That's all the delete operation. So hope it is easy to follow how to insert and delete elements in the linear array, and thanks for watching.